u.com.
Okay, welcome students. So in this session we are going to see the syllabus introduction and the first topic of unit 1. Okay, right? So that is a microprocessor architecture. So see the syllabus. So the objective of the syllabus is to understand the architecture of 8086 microprocessor. Okay, what is architecture? Architecture means the basic building blocks of the microprocessor. That means the internal structure of microprocessor we are going to study. Okay, what are the blocks inside, how it operates, how it helps to program, and how the microprocessor produce output. Okay, these things are we are going to study in this subject. Okay, then second objective is to learn the design aspects of IO and memory interfacing circuits. Okay, so learn the design aspects. So how to connect IO, that means input device and output device. Then how to interface memory with microprocessor. See, consider our mobile phone, we are having the memory card. Okay, that is a external memory. So the type of memory is how to connect with microprocessor we are going to study in this subject. And third objective is to interface microprocessor with supporting chips. Okay, so supporting chip means that is many interfacing ICs are available. That means serial port interface, parallel port interface, then keyboard interface, display interface. Okay, then DMI controller. Okay, likewise so many interfacing ICs are there. So how to interface with microprocessor. Okay, that is we are going to study in this subject. To study the architecture of 8051 microcontroller. So this is the second part of this subject. The first part is 8086 microprocessor and second part is 8051 microcontroller. Okay, so to study the architecture of 8051 microcontroller, that is also we are going to study. That is the architecture, the same set of 8086 microprocessor. Then to design microcontroller based system. So how to design one system that is based on microcontroller. That means how to design washing machine by using microcontroller, how to design traffic light controller by using microcontroller, and how to design a stepper motor interface by using 8051 microcontroller. Okay, these are some practical examples. These examples are we are going to study by using this subject. Okay, see this first unit. Is the 8086 microprocessor. We are going to study the architecture, addressing modes, then instructions, then programming. Okay, these are the first unit. We are completely studying the 8086 basis in first unit. That means architecture, addressing mode. Addressing mode means how microprocessor interface or identify the data that is stored in memory. Okay, then instructions. Instruction means the language. Okay, then directives, then assembly language programming, then modular programming. Okay, so the base is completely we are going to study in unit 1. And unit 2 we are going to study, that is a bus structure. Bus means already told, that is the group of wires. Okay, right, group of wires is a bus. So how the bus structure is present in 8086 microcontroller. Okay, in this we are going to study the signals of 8086. That means the pin diagram. Okay, then timing and system bus timing, how system bus is working, how system bus clock is working, how time delay is generated. Okay, then how to program the system bus. Okay, and then multi-programming and the multiprocessor configuration, then co-processor. Okay, these are the important topics we are going to study in unit 2. Okay, and unit 3 is IO interface. Okay, IO interface means that is how to interface input device and output device. Okay, so first we are going to study the memory interfacing and the IO interfacing. So in the IO interfacing we are having the parallel communication interface, that is a parallel port, then serial communication interface, that is a serial port, then digital to analog converter, analog to digital converter, timer, keyboard and display controller, interrupt controller, DMA controller, then applications based on this interface. They are, that is a traffic light controller, then LCD display interface, LED display interface, then keyboard and display interface, alarm controller. Okay, so these are completely practical oriented. So in unit 3 we are going to study, that is a basic interface with microprocessor, and how to develop the practical application by using microprocessor. Okay, first 3 unit is completely based on the microprocessor. Remaining 2 units is depends on microcontroller. The unit 4 is introduction of microcontroller. Microcontroller means 8051. Okay, that is the IC number is 8051. So how microcontroller is operating, then how the internal structure is present. Okay, then what are the registers present, then pin diagrams, then circuit diagram, then instructions, addressing mode and programming. These are the things we are going to study in unit 4. Unit 5 we are going to study, that is the interfacing with 8051 microcontroller. So that what are the interfacing, how to interface serial port, parallel port, and how to programming serial port programming, and how to interface LCD interface, how to interface keyboard, and ADC DS interface, how to connect sensor with microcontroller, how to interface external memory, then how to interface stepper motor, then how to generate waveform by using microcontroller. Okay, then comparison of microcontroller with microprocessor and advanced processor, that is advanced controller, that means PIC and ARM processors. These are the advanced controller. Okay, right. So in unit 5 we are going to study the interfacing with 8051 microcontroller. In unit 4 we are studying the basis of microcontroller. Okay, right. So after this subject you can understand the following things. Okay, so the students can understand and execute the program based on 886 microprocessor. Okay, that is the outcome of this subject. Okay, right. So at the end of the course the student should be able to understand and execute the programs based on 8086 microprocessor. So at the end of the semester you can be able to write the programs, assembly language program for 886 microprocessor and 8051 microcontroller, and you can design memory interfacing circuits, you can design the memory interfacing circuits, you can design IO interfacing circuits. Okay, then design and implement 8051 microcontroller based systems. Okay, these are the outcome of this subject or this course. Okay, right. So the textbook is that is a given textbook is you can follow, but in our college we are mostly using the Dr. Manokaran. Okay, so I will give the textbook name. Okay, and the link is given in description. Okay, you can buy the textbook through Amazon. Okay, right. So that is completely cover your whole units. Okay, all the units. So single book can cover the entire unit. Okay, so you can use that type of book. Okay, so see the description and you can buy the book from Amazon. Okay, right. So thank you. Next we are going to see the first topic of unit 1. Okay, that is the architecture of 8086 microprocessor. Okay, let us see. Okay, welcome back to 8086 internal architecture. Okay, so the 8086 employs the parallel processing. Okay, what is parallel processing? Parallel means இணையாக. Okay, right. So parallel processing means the processor execute one instructions, and at the same time the processor can do another operations. So simultaneously it will perform different operation. Okay, that is a parallel processing. So the 8086 CPU is divided into two parts, okay, which is operated at the same time. So that is called parallel processing. The two part is bus interface unit and execution unit. Okay, BIU and EU, bus interface unit and execution unit. Okay, so bus interface unit function is fetch the instruction from memory. Fetch means take instruction memory irundhu edukurathu. Okay, take. Then execution unit perform two functions, that is a decode and execute. In the memory, the instruction stored as a hexadecimal number, that number is decoded. Okay, then decoded information is given to execution unit. The execution unit execute the decoded instructions. Okay, so this is a basic blocks of 8086 CPU. Okay, so two units, one is bus interface unit, another one is a execution unit. Bus interface unit communicate with external world. Execution unit just perform the arithmetic and logical operations and produce the output. Okay, right. Then the bus interface unit functions. Okay, so the bus interface unit send out address for memory location. So bus interface unit communicate with the memory and IO. So it sends out the address of one data to the memory. If the bus interface unit fetch the instruction means the instruction present in memory, so the processor does not know the location of the instruction, so it sends the address of the particular instruction to memory. Then the memory receive the address, then is identify the data present in the memory, that means instructions. After the instruction identification, the microprocessor fetch the instruction from memory, that means take the instruction from memory. Then after that, after the fetching instruction, the fetched instruction is given to execution unit. Execution unit decode the instruction and execute the instruction and produce the output. Again the output is stored in memory by using bus interface unit. Okay, next step, the bus interface unit read or write the data to or from memory. Okay, then to read or write the data to memory, it first send out the address and write the data in memory. Similarly, in the bus interface unit interface IO port, that means IO port means the keyboard, mouse. Okay, in computer, same way in microprocessor, external sensor input. Okay, that is a input IO port, so it send out the address for IO port. Then the microprocessor read and write the data from IO port. Okay, so bus interface unit communicate between execution unit and memory or IO. Then execution unit, so execution unit tells the bus interfacing unit where to fetch the instruction or data. That means it inform the address of data or instruction to bus interface unit. Then after that, the bus interface unit take the data from memory based on the address given by execution unit, and the data is given to execution unit. Execution unit decode and execute the instructions. Okay, decode and execute the instruction. Okay, then the total work is divided between the bus interface unit and execution unit, so both are operated at the same time. so it increases the speed of operation. Okay, that is the basic 2 units of microprocessor. Next we are going to see the architecture diagram. Okay, so this is the architecture diagram. So in this diagram we are having so many blocks. The top half is bus interface unit and the lower half is execution unit. Okay, so bus interface unit and execution unit. So execution unit having the registers and arithmetic logic units and flags, then control system. And the bus interface unit having the segment registers and queue and memory interface, then memory interface control system. Okay, these are the basic building blocks of 8086 microprocessor, or the architecture of 8086 microprocessor. So if you have to draw the diagram the same format. Okay, so in this subject diagram is very important. Okay, right, so we will see one by one. First one we are going to see the execution unit. The execution unit having around 6 main part or component. First one, instruction decoder, then control system, arithmetic logic unit, general purpose registers, flag registers, pointer and index register. Okay, these are the important components of execution unit. Okay, right. First one I want to see one by one. Instruction decoder. So instruction decoder, that is decode the instruction that is fetched from memory in serious action. Okay, the instruction decoder is done by execution unit. Then control system. Control system means it generate or control the entire action, generate the timing and the control signal to perform internal operations of the microprocessor. Okay, perform the internal operation of the microprocessor. So it is generate timing signals. Okay, எப்போ ரீட் பண்ணணும், எப்போ ரைட் பண்ணணும். ஓகே, அப்போ இப்போ வந்து அந்த மெமரி ஆன் பண்ணணும், இப்போ மெமரி ஆஃப் பண்ணணும், இந்த மாதிரி கண்ட்ரோல் சிக்னல்ஸ் வந்து ப்ரொடியூஸ் பண்ணுறது கண்ட்ரோல் சிஸ்டம். ஓகே, தென் அரித்தமெட்டிக் லாஜிக் யூனிட். ஸோ எக்ஸிக்யூஷன் யூனிட் ஹேஸ் 16-bit arithmetic logic unit, so which can do arithmetic and logical operations. Arithmetic operation means the mathematical operations such as addition, subtraction, multiplication, division. Logical operations means that is or, and, not, nor. Okay, and binary shift, then increment, decrement. Okay, these are the logical operations. So these are performed by ALU. ALU is a 16-bit. Then general purpose registers. So the execution unit having many general purpose registers. First of all, what is register? Okay, register means what? Generally register அப்படின்னு சொல்லும்போது பதிவேடு அப்படின்னு தமிழில் சொல்லுவோம். ஸோ ஏதாவது இன்ஃபர்மேஷன் வந்து ஸ்டோர் பண்ணி வைக்கிறது. இப்போ அட்டண்டன்ஸ் ரெஜிஸ்டர்னால் உங்களுடைய அட்டண்டன்ஸ் வந்து ஸ்டோர் பண்ணி வச்சுட்டு இருக்குது. ஸோ ஜஸ்ட்டு நம்ம பதிவு பண்ணுறதுக்கு யூஸ் பண்ணுறது தான் ரெஜிஸ்டர். அதே மாதிரி தான் மைக்ரோ ப்ராசஸர் உள்ள நிறைய ரெஜிஸ்டர்ஸ் இருக்குது. ஸோ ஒவ்வொரு ரெஜிஸ்டரும் வந்து ஒவ்வொரு டேட்டா வந்து ஸ்டோர் பண்ணி வச்சுக்கோம். ஓகே, அது வந்து 16-bit ரெஜிஸ்டராகவும் இருக்கலாம் அல்லது 8-bit ரெஜிஸ்டராகவும் இருக்கலாம். 16-bit ரெஜிஸ்டர்னால் 16 டிஜிட்ஸை வந்து ஸ்டோர் பண்ணோம். 8-bit ரெஜிஸ்டர்னால் 8 டிஜிட்ஸை வந்து ஸ்டோர் பண்ணோம். இந்த டிஜிட்ஸ் அப்படின்னு என்ன சொல்கிறோன்னா 1 and 0. ஓகே, ஒன்ஸ் அண்டு ஜீரோஸை தான் இந்த டிஜிட்ஸ் அப்படின்னு சொல்கிறோம். ஸோ பைனரியில் வந்து நமக்கு எப்படி டெசிமல் நம்பரில் 0லேருந்து 9 வரைக்கும் இருக்குதோ அதே மாதிரி பைனரியில் வந்து 0வும் 1 தான் இருக்குது. ரெண்டு நம்பர்ஸ். அந்த நம்பரை வந்து ஸ்டோர் பண்ணுறது வந்து இந்த ரெஜிஸ்டர்ஸ். ஓகே, நம்ம மெமரி கார்டு உள்ளேயும் ரெஜிஸ்டர்ஸ் தான் இருக்குது. ஸோ அதில் வந்து நிறைய ரெஜிஸ்டர்ஸ் இருக்குது. ஸோ நமக்கு அந்த ரெஜிஸ்டரை பொறுத்து தான் மெமரி வந்து கால்குலேட் பண்ணுறோம். ஓகே, ரைட். ஸோ அதே மாதிரி தான் இந்த ஜென்ரல் பர்பஸ் ரெஜிஸ்டர் இருக்குது. ஓகே, ஸோ the execution unit has 8 general purpose registers. Okay, it can be individually used for storing 8-bit or combined only we can use as a 16 bit. Okay, so AH and AL. H means high, L means low. A lower. A represent accumulator. Okay, A represent accumulator. So it is a 16 bit register. We can store 16 bit data, or we can store 8 bit data accordingly. Okay, similarly B, C and D. Okay, these are the general purpose register. A register is always called as accumulator. Why is accumulator? Means A can store data during the time of mathematical operations or arithmetic and logical operations. Okay, and the result is also stored in accumulator only. Okay, so that it is A register is called as accumulator. Then the valid register pair, that is a AX, BX, CX, DX. So we can combine A, AH and AL. We cannot combine AH with BL or CL and DL. Okay, so A is a single register. It is divided into 2 8 bit, that is a AL and AH. Okay, so these are general purpose registers. Okay, see AH plus AL equal to AX. X represent 16 bit register. Okay, L and H represent lower and higher, that is a 8 bit register. Okay, right. Next, flag register. What is flag? ஜென்ரலாக தமிழில் சொல்ல போனால் ஃப்ளாக்னா அது கொடி. ஓகே, கொடி எதுக்கு யூஸ் பண்ணுவோம்? ஏதாவது ஒரு சிக்னல் காமிக்கிறதுக்காக யூஸ் பண்ணுவோம். இப்போ ரெட் கலர் காமிச்சா நம்ம வந்து ரோடில் வந்து நிற்கிறோம். ஓகே, க்ரீன் கலர் காமிச்சா நம்ம மூவ் ஆகிறோம். ஓகே, இதுதான் வந்து சிக்னல். அதே போல் தான் மைக்ரோ ப்ராசஸரில் அந்த இன்டர்னல் என்னென்ன நடக்குது அப்படிங்கிறத அந்த ரெஜிஸ்டர் ஃப்ளாக் மூலமாக நமக்கு சொல்லுவாங்க. ஓகே, இப்போ வந்து என்னென்ன நடக்கும்? ஆக்சுவலி இப்போ ரிசல்ட் வந்து நெகட்டிவ்னா நெகட்டிவ் ஃப்ளாக் வந்து 1 செட் ஆகும், 1 அப்படின்னு காமிக்கும். நெகட்டிவ் ஃப்ளாக் 0னா அந்த ரிசல்ட் வந்து பாசிட்டிவ். ஓகே, ஸோ அந்த மாதிரி பாசிட்டிவ் நம்பரா நெகட்டிவ் நம்பரா. ஓகே, அதுக்கப்புறம் ஆட் நம்பர் ஆஃப் ஒன்ஸா ஈவன் நம்பர் ஆஃப் ஒன்ஸா, அதை பேரிட்டி அப்படின்னு சொல்லுவாங்க. ஓகே, நம்ம ஒன்று வேணால் பார்க்கலாம். ஓகே, ஸோ 886 இயர்ஸ் 16 பிட் ஃப்ளாக் ரெஜிஸ்டர். ஓகே, 16 பிட் ஃப்ளாக் ரெஜிஸ்டர் இருக்குது. அதில் வந்து 9 active flags are there. Okay, totally 9 flags are there. There are 2 type of flag in 886. One is the conditional flag and another one is control flag. Conditional flag is 6 flag. It is set or reset by execution unit on the basis of result of some arithmetic operations. Okay, that is a conditional flag. Control flag means 3 flag, that is used to control certain operation of the processor. Okay, these are the flag registers. Okay, right. So what is register? This is a 16 bit register. Here U represent undefined. U represent undefined. Okay, that is a see, this is a U, the black color U represent undefined. Okay, we will say one by one. The first flag is CF. CF means carry flag. Okay, and the second flag is PF. PF means parity flag. And third one AF, that is a auxiliary carry flag. Then ZF, that is a zero flag. Then SF, that is a sign flag. Then OF, that is overflow flag. These 6 flags are conditional flags. Okay, it is compatible with 8085 except overflow flag. Okay, then 3 flags are control flags, that is trap, interrupt, then direction flag. Trap flag, interrupt flag, direction flag. Okay, these are the control flag. So this is a flag register. We will see one by one. So first one, carry flag. What is carry? What is carry generally? So max la addition பண்றோம். Okay, 6 plus 7 அப்படின்னு சொல்றோம். So 13 வரும். சம்ல வந்து 13 3 கீழ போடுவோம். அந்த 1 வந்து அடுத்த நம்பரோட ஆட் பண்ணுவோம். That is the 1 is carry. Okay, so this is a flag. This flag is set when there is a carry out of MSB in case of addition or borrow in case of subtraction. What is MSB? MSB. M means maximum, S means significant, B means bit. MSB means maximum significant bit. அதாவது லாஸ்ட் பிட். இப்போ ஒரு 16 பிட் இருக்குன்னா அந்த எம்எஸ்பி அப்படிங்கிறது இந்த 15th பிட் இதான் வந்து எம்எஸ்பி. ஓகே, ஒரு 16 பிட் நம்பர் இருக்குன்னா இந்த நம்பரில் வந்து ஒரு கேரி ஜென்ரேட் ஆச்சுன்னு வச்சுக்கோங்களேன். ஸோ 2 16 பிட் நம்பரை ஆட் பண்ணுறோம். ஸோ லாஸ்ட் நம்பர் வந்து கேரி ஜென்ரேட் ஆச்சுன்னா அதுக்கு பேர் என்னது? கேரி ஃப்ளாக். The flag is set when there is a carry out of MSB in case of addition, borrow in case of subtraction. Okay, this is the first one. And the second one is parity flag. Parity means even parity or odd parity. So this flag is set to 1. So next one is auxiliary carry flag. Okay, so carry flag means the carry out from MSB. Okay, but auxiliary carry means carry out from lower nipple. Lower nipple means 4 bit. Okay, so bit 3 during addition or borrow for the lowest nipple, therefore bit 3 during subtraction. Okay, so there is a this is set if is a carry from the lowest nipple. Okay, that is a auxiliary carry, so don't confuse with carry and auxiliary carry flag. Next one is zero flag. Zero flag is set when the result is 0. Okay, so the zero flag is set when the result is 0. So that is result of computation or comparison performed by instruction. Okay, that is 0. So comparison, if you are comparing two number means the 0 the output is which same means the output is 0. Okay, with different means the output is 1. So that time it will show the comparison result is same or not. Okay, the next one is sign flag. Sign flag is set when the result of the computation is negative. So this flag set means set அப்படின்னா என்னன்னா அந்த வேல்யூ வந்து 1 இருக்கும், ரீசெட்னா 0 இருக்கும். ஓகே, ஸோ சைன் ஃப்ளாக் வந்து 1 அப்படின்னா என்னென்னா ரிசல்ட் வந்து நெகட்டிவ் நம்பராக இருந்துச்சுன்னா அந்த எஸ்எஃப் ஈக்குவல் டு 1 அப்படின்னு இருக்கும். எஸ்எஃப் ஈக்குவல் டு 0னா ரிசல்ட் வந்து பாசிட்டிவாக இருக்கும். நெக்ஸ்ட் வந்து டிஎஃப், ட்ராப் ஃப்ளாக். If this flag is set, the processor enter the single step execution mode. Okay, by generating internal interrupt after the execution of the each instruction. ட்ராப்ங்கிறது என்னென்னா அது இது வந்து தட் இஸ் அ இம்பார்ட்டன்ட் ஃப்ளாக். ஸோ ட்ராப்ங்கிறது ஜென்ரலாக சொல்லப்போனால் பொறி அப்படின்னு சொல்லுவாங்க. ஸோ ஒவ்வொரு இன்ஸ்ட்ரக்ஷன் எக்ஸிக்யூட் உடனே இந்த ஒரு இன்டரப்ட் வந்து ஜென்ரேட் ஆகும். இன்டரப்ட்ங்கிறது தடை, ஒரு தடை வந்து ஜென்ரேட் ஆகும். ஓகே, ஸோ இது வந்து டிஎஃப் ஈக்குவல் டு 1 அப்படின்னா ஒவ்வொரு டைம் இந்த ஒரு இன்டரப்ட் வந்து ஜென்ரேட் ஆகிட்டு ஒவ்வொரு இன்ஸ்ட்ரக்ஷன் எக்ஸிக்யூட் ஆகும்போது ஒரு இன்டரப்ட் ஜென்ரேட் ஆகிட்டே இருக்கும். தட் இஸ் அ ட்ராப் ஃப்ளாக். அப்புறம் பார்த்தீங்கன்னா இன்டரப்ட் ஃப்ளாக். ஓகே, ஸோ it caused the 886 recognize external mask interrupt. Okay, cleaning IF disables these interrupts. Okay, cause the 886 to recognize external mask interrupt. Okay, so IF is interrupt flag cause the 886 to recognize the external interrupt. External interrupt na வெளியிலிருந்து வரக்கூடிய ஒரு தடை அப்படின்னு சொன்னாக்கா ஸோ தட் இஸ் அ எக்ஸ்டர்னல் இன்டரப்ட். அந்த மாதிரி எக்ஸ்டர்னல் இன்டரப்ட் வந்துச்சுன்னா ஐஎஃப் ஈக்குவல் டு 1. த நெக்ஸ்ட் ஒன் இஸ் டைரக்ஷன் ஃப்ளாக். ஸோ திஸ் இஸ் யூஸ்டு பை ஸ்ட்ரிங் மேனிப்புலேஷன் இன்ஸ்ட்ரக்ஷன்ஸ். ஸ்ட்ரிங் மேனிப்புலேஷன் மீன்ஸ் text manipulation. Okay, we can handle the text. Okay, if this flag fit is 0, the string is processed beginning from the lowest address to the highest address. That means lowest to highest address, that is ascending order. So auto increment mode. Otherwise the string processed from highest address to lowest address auto incrementing mode. That means that is auto incrementing mode. Okay, it indicates upward or downward direction. And the last flag is overflow flag. So this flag is set if the overflow occurs. Therefore, if the result of the signed operation is large enough to accomplish the destination of the register. So if you are multiplying two 16-bit number, so the result is in 32-bit. Okay. So after multiplying two 16-bit number, the result is 32-bit. So what will happen? So accumulator can store 16-bit only. Okay. So remaining 16-bit is stored in D register. So this is the overflow. Okay. So the large enough to accommodate the destination register. This result is more than 7-bit in size of 8-bit register signed operations. The more than 15-bit size in case of 16-bit signed operation. That is the overflow will be set. Okay. Overflow will be set. Okay. So this flag is 1. So we are having a signed operation of signed operation at 15th bit in 16-bit operations, 7th bit in 8-bit signed operations. Okay. These are the flag registers. It's an important 2 mark question. Okay. Next, registers and flags. Okay. So general purpose register, it's a total combination of all the registers present here. So it is a 16-bit AX, BX, CX, DX, and 8-bit AL, AH, BL, BH, like that. Pointer register, stack pointer, base pointer, SP, BP. Index register, that is also 16-bit, source index, destination index. Instruction pointer, IP, that is a 16-bit register. Segment register, code segment, data segment, stack segment, extra segment. And flag register, that is program status word. Okay, that is also flag register, that is a 16-bit register. Okay. These are the total registers present in 886 microprocessor. Okay. Then the operation and the special function of the each register. So AX means 16-bit accumulator, store 16-bit result of arithmetic and logical operations. So after the addition and subtraction or whatever may be the operation, the result is stored in accumulator. Okay. Then AL is a 8-bit accumulator. It stores the 8-bit result of arithmetic and logical operations. Base register, that is used to hold base value in base addressing mode to access memory data. Okay. So we will see the addressing mode later. So at the time we can understand what is base register. Okay. Then CX is a count register, that is used to hold the count value if in shift, rotate, and loop instructions. Okay. So in C program we are using for loop. Okay, for loop la vandu I equal to 0, then I equal to I some maximum value, then I plus plus அப்படினு சொல்லுவோம். ஸோ இதை வந்து ஒரு லூப் கிரியேட் பண்ணோம். ஓகே, அந்த ஐ வேல்யூ ஒன் பை ஒன்னாக இன்க்ரீஸ் ஆகிட்டே இருக்கும். அந்த மாதிரி கவுண்ட் வேல்யூக்கு we are using CX register. The data register, that is a DX register, is to hold the data for multiplication and division operations. Okay. So multiplication and division operation பண்ணும்போது அந்த எக்ஸ்ட்ரா உள்ள டேட்டா வந்து இந்த டேட்டா ரெஜிஸ்டரில் ஸ்டோர் ஆகும். ஓகே. தென் ஸ்டாக் பாயிண்டர் இஸ் டு ஹோல்ட் த ஆஃப்செட் அட்ரஸ் ஆஃப் டாப் ஸ்டாக் மெமரி. இஸ் டு ஹோல்ட் த ஆஃப்செட் அட்ரஸ் ஆஃப் டாப் ஸ்டாக் மெமரி. ஓகே, தட்ஸ் அ ஸ்டாக் பாயிண்டர். That is a top stack memory. Okay, stack pointer is to hold the address of stack. Base pointer is to hold the base value in base addressing using stack register, stack segment register to access the data from stack memory. Okay, is to hold the base value in base addressing using stack register. Okay, that is a stack segment registers. Okay. Then source index is to hold the 16-bit address. Okay, source operand or data or address. Similarly, destination index is to hold the index value of the destination operand for string operations. Okay, that is a register and special function registers. Next one, you are going to see the next part, that is a bus interface unit. So it having three part, that is a instruction queue, segment register, then instruction pointer. Okay, these are the bus interface unit. Okay, right. So this is the bus interface unit, the lower part. So having higher part, segment register, instruction pointer, and instruction queue. These are the major three part is in bus interface unit. First one, I already told that 8086 perform parallel processing. Okay, when the execution unit decoding or executing the current instruction, the bus interface unit may not be in use. The buses of 8086 may not be in use. Okay, actually, when execution unit is busy, the bus of 8086 is free. Okay, at the time, the bus interface unit can use the buses to fetch up to 6 instruction bytes from the following instructions. So when execution unit busy, at the time bus interface unit fetch the instruction, so that is around 6 instruction and store the instruction in instruction queue. So the bus interface unit store this prefetched byte into first in first out register is called as instruction queue. So the instruction queue stores 6 bytes of instructions, that is first in first out basis. When execution unit is ready for next instruction, it simply read the instruction from the queue in bus interface unit, so that increases speed of the operation. Okay, so when execution unit is busy, at the time bus interface unit is fetch the instruction from memory. So around 6 instruction is fetched from memory, that is stored in bus interface unit, queue. Then when execution unit is complete its operation, next it's take the instruction from bus interface unit. Okay, then pipelining. Execution unit of 8086 does not have to wait in between bus interface unit to fetch the next instruction byte from memory. Okay, so the presence of queue is 8086 speed of the processing. Fetching the next instruction while the current instruction is executed is called as pipelining. So current instruction is executing, at the same time the bus interface unit fetch the next instruction, so that is a parallel operation, that is called pipelining. Okay, so same time one instruction is executing and one instruction is fetched from memory and one instruction is in decoding. So 3 different operations in same time, that is called pipelining. Okay, then memory segmentation. Okay, how the memory is segmented in 8086 microprocessor. So the memory segmentation is based on address bus. So 8086 has 20-bit address bus and it has 16-bit data bus. Data bus is 16-bit, address bus is 20-bit length. So it can address maximum of 1 MB of memory. Okay, so the 1 MB, how it is came is 2 power 20 equal to 1 megabytes. Okay, so 2 power 20 equal to 1 megabytes. The 8086 can work with only 4 64 KB segments at the time within a 1 MB range. 4 64 KB segments, so that we are having 4 different segment registers, that is core segment, stack segment, data segment, extra segment. These 4 segments are very important. Each segment has 64 KB memory. Okay, see, this is a entire memory. So the addresses start from 00000 and end at FFF. The total length is 1 megabytes. Okay, 1 megabytes. So first one is first segment, that is a 64 KB. Okay, that's the first segment. And the second one, second is only 4 such segment can be addressed at a time. Okay, so this is another segment. Okay, so this is a memory structure. Okay, then code segment. So the memory from bus interface unit is currently fetching the instruction code byte. The code segment that only store the code, means instructions. Stack segment, that is a section of memory set aside to store the address and data while subprogram executes. Okay, whenever the subprogram is executes, at the time the address and data is temporarily stored in stack. Then data and the extra segment is used for storing data values to be used in program. Okay, these are the data and extra segments. Okay, see again we are going to see the memory. That is a capacity is 1 MB. So first one is code segment, then 5/6 is a data and extra segment, last one is a stack segment. Each segment register has 64 kilobytes. Okay, so that is a segment registers. Okay, then so segment registers can hold upper system bit of starting address for each of the segments. The 4 segment register, that is a code segment, data segment, stack segment, extra segment registers. Okay, so code segment and data segment, extra segment and stack segment. So code segment starting address is 1000, data segment starting address is 4000, extra segment starting address 5000, stack segment starting address F220. Okay. Then these are the starting address of the each segment. Okay, so that is a code segment, data segment, extra segment, stack segment starting address. See, then the 0 is a extra higher byte, that is indicate the 20-bit address. Okay, so microprocessor address lines are 20 bits. So, okay, the first 4 bit is only 0, the remaining system bit is a offset. Okay, that is a memory address. So the address of segment is 20 bits. The segment register store only upper 16 bit. Okay, so bus interface unit always insert zeros for the lowest 4 bit of 20 bit starting address. Okay, that is a important thing. So actually the address is 20 bits total length, but the segment register use only 16 bit. So the lower 4 bit is 0, so it gives 20 bit address. For example, code segment starting address equal to 348A, H represent hexadecimal. Then the code segment start at 348A0H, H represent hexadecimal. A 64 KB segment can be located anywhere in the memory, but will start at an address with 0 in the lowest 4 bits. Okay, that is a segment address. Okay, then instruction pointer. Instruction pointer is a 16-bit register which holds 16-bit offset, that means address of the next instruction. Offset represent address, okay, in the code segment. Bus interface unit uses instruction pointer and code segment register to generate 20-bit address of the instruction to be fetched from memory. Okay, so this is the instruction pointer register. And physical address calculation. So this is a memory, that's a 1 MB addressable memory by microprocessor. For example, code segment, consider code segment. So that starting address is 348A0. Okay, code segment starting address is 348A0H. So code segment address is 348A only. The 0 is not considered, only 16-bit address is considered. Then consider one instruction that is present at 38AB4H. Okay, so 38AB4H, that's the location. Okay, so the physical address is 20-bit, so 38AB4. Then the distance between the starting address and the instruction is that is a IP, that is instruction pointer. Instruction pointer hold the distance between starting address and the data present in the memory. Okay, so the physical address is calculated as code segment address, that means CS address. Okay, starting address, that is 348A0. So here we can consider 0, here we can consider 0 plus instruction pointer. Instruction pointer hold some value, so both are added, so we can head 20-bit address, that is a physical address. Okay, so the physical address indicate the instruction in the memory. Okay, so 0 is considered. Okay, Then stack segment, stack pointer. Okay, upper 16 bit of the starting address of the stack segment is stored in stack segment register. It is located in bus interface unit. Stack pointer register hold 16 bit offset from the start of the stack segment to the top of the stack. So stack segment register as a 16 bit address. Okay, it is located in execution unit. Okay, so stack segment is present in bus interface unit, stack pointer is present in execution unit. So stack pointer hold a 16 bit offset from the start of the stack segment to the top of the stack. Okay, great. Then other pointer and index register. So some other pointer and index register, that is base pointer, that is a BP, source index SI, destination index DI. So these three registers are 16 bit register. It can store the address of data or in a memory. It can be used to temporary storage of data. Main use is to hold the 16 bit offset, another name address, 16 bit address of the data word in one of the segment. Okay, it is mainly used to store the 16 bit address or offset. Okay, right. So this is a addressing architecture of 886. So up to this we have studied the architecture of 886 microprocessor. So this so you have to draw this block diagram, then you can explain every blocks. Okay, so very important question. This question is asked in many time in university examination. Okay, so study well, then take notes. Okay, all should take notes. Then if you have any doubt, you can ask in Google Meet. Okay, so thank you students. So share this video with your friends in other colleges. Okay, then like and subscribe. If you not subscribe, please subscribe this channel. Okay, so thank you so much. Thank you.